Hello, we have a problem from section 4.1, problem number 30. Now, a lot of you guys haven't got to this point yet. My online students have, but this is a problem that asks if you have two functions, f of x equals 4x minus 3 and g of x equals negative 3x plus 4. And they want the answer to these questions. What is, if you solve f of x equals 0, solve g of x equals 0, solve the equation f of x equals g of x, solve for when f of x is greater than g of x, and graph both, labeling the solution of f of x equals g of x. So let's take the A first. Solve for f of x equals 0. So if you're going to solve for f of x equals 0, what you're basically asking is, when is 4x minus 3 equal to 0? So in other words, what value of x makes the y-coordinate f of x, that's the y-coordinate, equal to 0? And if you solve for x, x turns out to be 3/4. So really what that's actually doing is, on the graph of this, there'd be an x-intercept of 3/4, comma 0, because the y is 0. So that answers A, though. X is 3/4. That will make the function equal to 0. The next question on part B is, when is g of x equal to 0? So it's the same idea. Different function though. This one's going to be a negative 3x plus 4 equal to 0. So again, you're being asked for the x-coordinate when the y-coordinate, in this case g of x, equals 0. So solving this one for x, I believe you get negative 3x equals negative 4, and so x turns out to be 4/3. So g of x has an x-coordinate of 4/3, comma 0. So that's A and that's B. Now C is want to know when the functions are equal to each other. So now in a graph, which we're going to graph in a minute, in part E, you're going to see what that really means. But you're basically being asked, well, where is the y-coordinate of f of x and the g of x? When do they have the same y-coordinate? So if you think about it, these are both lines. We learned that in 2.3. And these two lines, one's actually increasing and one is decreasing, okay, because of the positive and negative slopes. So if one line is going up and one line is going the other direction, they're going to cross somewhere. So we're trying to figure out where these things are going to cross. And this equation, setting f of x and g of x equal to each other, setting their y-coordinates, that means they're on the same level. That means they're going to have the same. We're trying to figure out where their x-coordinates are going to be the same. So we set 4x minus 3, which is f of x, and set that equal to negative 3x plus 4. So if you solve that equation, you add 3x to this side, and that's 7x. And you add 3 to the right side, and 3 plus 4 is 7. So 7x equals 7. So divide by 7, x has a value of 1. So at the x-coordinate of 1, and I want to be a little bit more specific later, but right now you got one function, x equals 1. You got one function going one way, and you got another function going another way, but they cross at x equals 1. That's what this is indicating. And later on, we're going to figure exactly what that point is. Well, we can do it right now. If we plug 1 back into one of the equations, negative 3 times 1 is negative 3, plus 4 is 1. So the ordered pair is 1, 1. And that kind of looks like that's where that's at, actually. 1, 1. Okay? And then that's A, B, C. Now D is asking, where is f of x greater than g of x? So on this one, it looks like that. And you just set 4x minus 3 greater than or equal to negative 3x plus 4. This solves exactly the same way, and but it ends up being that x is greater than or equal to 1. So what they're basically saying is the function, this must be f of x, and yeah, that's f of x, and that's g of x. And to the right of 1, the function f of x is greater than g of x. And if you notice, that's exactly what the case is. F of x is up here, and g of x is down here. It's higher than g of x. So that's really what that is saying. And part E is asking you to graph both. And so if you graph both of them, you have f of x equals 4x minus 3, so y-intercept of negative 3, and has a slope of 4, so you rise 4 and you run 1. So it's right there at that 1, 1 point we found a while ago that they cross. So 4x minus 3 has that shape. That's f of x. And the one that I kind of traced a while ago, there was your f of x. This is not quite as steep as the actual graph, but that's what it is right there. And g of x is negative 3x plus 4, so it has a y-intercept of 4. And it has a slope of negative 3, so you go down 3, 1, 2, 3, and over 1. Happens to be at the same point, which is what we said a while ago. And so these cross there. Okay? And like I said a while ago, it says graph both, labeling the solution of the f of x equals g of x. So where are they the same? What's the ordered pair that they cross at? And like we said a while ago, that is at 1, 1. So when we did that a while ago, we kind of got ahead of ourselves because that was actually the second part of E, the answers that they wanted. But yeah, it's like a 5-part problem. F of x is 1 to 1 the y coordinate equals 0 for fx solve for x. And so really what that is doing is basically finding the x-intercept. Like I said, we'll go 3/4 comma 0. And if you notice, that's exactly where f of x looks like it's crossing. And on this one, when you did g of x equals 0, x equals 4/3. And if you look at there, this is g right here. And here's 1, here's 2. And g of x does look like it's at 4/3. Actually, it's 1 1/3. So it does look like it's pretty accurate. So that's what these two are doing, just finding their x-intercepts. And that's it.